The blockchain industry is poised for massive growth and expansion, especially in the upcoming 2024 year. With Bitcoin at the time of recording this video up 117%, and with the Bitcoin halving coming in April of 2024, we're poised for the next wave of crypto onboarding and massive gains. But in order to land yourself a lucrative six-figure paying gig, you have to have the skills to pay the bills. Today, we're going to be going over a to-do contract, which will be going over the basic CRUD operations: create, read, update, and delete, and how to implement that into the blockchain. My name is Anthony with the Blockchain Dojo, where we teach you how to become a blockchain ninja. If you like what you learn, or if you learn something new, please like and subscribe for more content. Let's get started. Today we're going over a blockchain-based to-do smart contract. This smart contract goes over the basics of the Solidity programming language, going over the create, read, update, and delete functions, which ultimately are how everyone utilizes every single program in some sort of fashion. This tutorial will teach you the basics of how to read data from the blockchain and write data to the blockchain, and how to implement that into your own contract. We'll also be going over how to test your smart contracts and testing the to-do contract, as well as testing the CRUD functions to ensure that everything is operating correctly. Let's get started. To get started with our to-do smart contract, the first thing we do is we put in the license identifier and then declare the Pragma Solidity version for the compiler that we'll be working with. Second, what we do is we declare the contract and we label it to do. And then I always like to instantiate an owner variable. And in order to do that, Solidity utilizes static typed variables. So what we do is we declare the type of the variable, which is address, and then we declare the visibility, which is public. A public visibility allows outside users to read this data directly from the blockchain. Do not get that confused with private variables, as private variables still can have that data read from the blockchain, as the blockchain is a public ledger. Next, I declare a uint 256 variable with the public visibility of to-do count. This is where we're going to be keeping track of the to-dos and the number of to-dos that we are going to be doing. Next, we have a to-do struct. So this struct is a complex data type which combines the string item and then the bool of completed. What this struct does is this is going to represent our actual to-do item with what we have to do and whether it's been completed or not. Next, for this to-do contract, we have our events. We have an added to-do, a completed to-do, and a deleted to-do, where we index the to-do number and then the timestamp that the to-do was completed. What an event does is an event actually broadcasts or emits this information for other applications and developers to read and react to. Up next, we have our modifier, and this is going to be an only owner modifier, which takes this require statement to ensure that the message.sender is equal to the owner, and then this underscore tells the compiler to run the rest of the code. We'll go over that further down here in the add to do function. After that, we have a mapping of uint to the to-do struct, and this is a private mapping for the to-dos, labeled to-dos. What this does is it maps the to-do count to the struct, or the complex data type for the to-do item. Following, we have the constructor. The constructor is run once and only once when the contract is actually deployed. And when this contract is deployed, we are assigning the owner variable is going to be equal to the message.sender, which is saying that the owner is the deployer of the contract. Next, what we have is our create function. So what this is going to take in a string from memory labeled item, and it's going to actually do two things. It's going to increment the to-do count, and then it's going to take that mapping, this private to-do mapping with the current to-do count, and then it is going to instantiate the to-do struct with the item passed into memory, and then we're passing in the false boolean as the item has not been completed yet. As mentioned, we have the only owner modifier on here. So what this essentially does is it takes this statement right here, this require statement, and puts it at the front of the function. And then this underscore tells the remainder of the function to run should this require statement be met. And then finally, with this create function, what we do is we emit an added to do event, which allows other blockchain developers and dApps to react and respond to the added to do. Next, we have our update. So our update function takes in, we actually have two different update functions. So our update function takes in the to-do number and then completes the to-do so that the Boolean of the completed is equal to true. Again, we have our only owner modifier on this. And then the other update function is similar, but what we do is we take in the to-do number and then the updated to-do item, where we take the to-dos, we pass in the to-do number to reference the spot in the mapping, and then we take the item part of that struct and we equal it to the new updated item. Next, we have the delete. With delete, we take in the to-do number, and then what we do is we pass in the completed Boolean to false. We set the to-do number dot item to be equal to an empty string, and then we emit the to-do event. And then finally, for our read function, we have our return to do, which takes in a to do number and then just returns the to do struct from the to do's private mapping. That was our to do contract, where we're able to upload and update to do's as well as complete them out and delete them out of our mapping. Up next, we're going to go over the basic testing in order to check to ensure that these CRUD operations are returning the appropriate output. In order to test our to-do contract, what we're going to be utilizing is the Mocha and Chai framework within the Hard Hat framework. So first, what we do is we declare the expect statement from the Chai library, and then the Hard Hat runtime environment from Hard Hat. Next, what we do is we create an outer describe block, which we label to-do contract. This is going to encompass all of our tests. From here, we declare the to-do variable, the deployer variable, and user one. With the Mocha and Chai framework, we have a before each clause, which this is actually going to be run before each and every single one of these statements below it. This is going to save out having to repeat a lot of the same code over and over again. Before each, we assign the deployer and the user to the ethers get signers array that's returned from this statement. And then we deploy the to-do contract through the hre.ethers.deploy contract to do. Now our constructor did not take in any parameters, so we are not passing any parameters into this deployments. Next, what we do is we describe the deployment. So when we describe deployment, we want to ensure that the constructor is run properly and the correct variables are assigned. So first, what we do is we check that the deployer is the owner, and then we check that the to-do count is initialized at 0. Following that, in a separate describe block, we're going to check the CRUD operations, which is the create, read, update, and delete. While we create and declare the transaction, response, the to-do item, and the mapping item. In a similar before each statement, we're going to assign the to-do item to code. We're going to have the transaction assigned to the to-do contract connecting the deployer, and then initializing or calling the add to-do function, passing in the to-do item. We wait for the response, and then the map item is going to be the read function for the returning of the to-do, passing in the current to-do count. In this block here, we're going to be describing the add to-do and the success. So in the success, we expect that once we add the to-do count should equal 1. We also want to expect that the mapped item is going to be equal to the to-do item, which is declared here, and that the map item.completed is going to be equal to false. This is because when we add a to-do, we declare and initiate the completed item on the struct to false. Next, we want to check that the add to do event was emitted. And then after we check for success, we always want to check for failure as well. So we want to make sure that other users cannot connect to our to-do contract and add to-dos. So with that, we try to connect with our user one to the to-do contract and add to-do, and we expect it to be reverted with only owner. In the next describe block, we're going to be updating and completing the to-do. So describing the success here, we're going to run another before each, which is going to update and complete out the to-do. Now this is going to check that the updated to-do completed is equal to true, as well as this is going to check that the item is going to be equal to new test, meaning we're updating it from code to new test. Next, we want to check that the update and complete event was emitted. So once we call the add to do, we're going to expect that the complete to do is going to emit the completed to do event. And then we want to describe failure. When describing failure, you want to ensure that the other users cannot connect to your contract to update and complete out your to-dos. And then finally, we have the last describe block where we're going over the delete operation, where the success case looks like this, where the map item is going to be expected to be equal an empty string, as well as that the event was emitted. And then finally, the failure case is going to be that the user 1 cannot delete a to-do as well, and it's reverted with only owner. The CRUD operations are a staple in every programming language. In today's video, we went over the basic CRUD operations when it comes to writing your own to-do smart contract. You can utilize these principles and concepts to write your own smart contract, whether it includes NFTs, ERC contracts, or even your own social media profile contract. If you learned something new, please like and subscribe, and stay tuned for more content.